Oil and gas, also known as hydrocarbons, provide much of the energy needed to power homes, cities, and industries around the world. Offshore wells are drilled by energy companies to discover oil and gas, or to develop and produce already discovered reservoirs for processing into usable energy. Before drilling, companies undertake detailed well design and logistical planning. Stakeholder consultation is an important part of the process, including engagement with local communities and fishers to explain planned activities and understand how potential impacts can be avoided or reduced. These potential impacts and other possible hazards associated with drilling activity are monitored and managed throughout operations. Companies also prepare environment plans detailing how drilling will be undertaken and obtain approval from relevant regulatory authorities before operations begin. Wells can be drilled by either a drill ship or a drill rig, depending on water depths and other factors. To ensure the safety of other marine users, vessels not involved in drilling should stay at least 500 meters away from the drilling location while operations are underway. This is called a safety exclusion zone. While technical differences exist, the process for drilling offshore wells is broadly similar and takes place in several stages. Before any drilling, a remotely operated vehicle is sent to assess the condition of the seabed. A hole is then drilled into the ocean floor using a large diameter drill bit, and a steel pipe called a conductor is installed to provide the well's initial structural support. A smaller drill bit is then lowered through the conductor to drill the next section, known as the top hole. Once it reaches a predetermined depth, more steel pipe called casing is installed to support the newly drilled hole. Cement is pumped through the casing, filling the space between the casing and the drilled hole to secure it in place. The cement is allowed to set before drilling continues. Before drilling deeper, a blowout preventer is installed on top of the well. The blowout preventer is a large, specialized safety device used to seal, control, and monitor wells to prevent the uncontrolled release of fluids. Once the blowout preventer is in place, a smaller drill bit is used to continue drilling, and additional casing is cemented in as needed. This step is repeated until the well reaches a specific depth where the targeted reservoir is predicted or known to sit. This is called total depth and can be several thousand meters below the seabed. Drilling fluid, sometimes called mud, is continuously pumped into the hole while drilling. This helps keep the drill bit lubricated and cool to prevent overheating, prevents the uncontrolled flow of wellbore fluids, and transports drilled rock cuttings back on board. Fluid is returned to tanks on board the rig. Where required, cuttings undergo additional processing before being carefully discharged below sea level. The volume and properties of drilling fluid are continually monitored to ensure the well is drilled safely. Once total depth is reached, tests are run to understand the geological properties of the intersected rocks. Information on any hydrocarbons found is collected through rock and fluid sampling. The information gathered can be used in a variety of ways, such as informing future exploration activities, development planning, or optimizing production. Once wells reach the end of their life, they are made safe by sealing them with cement. This is called well abandonment. Before leaving the location, a remotely operated vehicle surveys the seabed again to assess and record the condition of the area. Companies are committed to strong health, safety, and environmental performance in drilling activities. This includes world-class environmental management and exploration, design, construction, and operation of facilities to help meet the world's future energy needs.